Good morning, good evening, good noon, depending on the geographical location in which you are located. This lecture series is known as Padma Shri Dr. SR Valluri Memorial Lecture Series. This is held on all Saturdays. Timings: evening 6 p.m. to 8 p.m. as per Indian Standard Time. This is a virtual program through Zoom. All are welcome irrespective of their geographical locations. Thanks to Corona for having made this possible. The topic for discussion for the 12th session on Zoom meeting platform on today, which is Saturday 26th February 2022 from 6 p.m. to 8 p.m. as per Indian Standard Time is user-friendly interactive C programming part 3. Learn free from any place. Learn free at any time. Learn free at any pace. This is an Atmanirbhar Bharata initiative. The program is called as lecture series. However, wherever possible, discussion method will be utilized to the extent possible for exchange of ideas among the participants, including but not limited to the speaker, for the purpose of encouraging everybody in terms of thinking, in terms of learning, in terms of problem solving, and in terms of understanding the topic of interest. The resulting multiple points of view is expected to help to build better knowledge, better understanding, and better interpretation of the topic discussed. Disclaimer: the information contained in this program is collected from several sources and studied, simplified, and standardized, and efforts have been made to see that it is error-free. But every keystroke is itself an important source of error. Hence, the participants as well as viewers are required to use the information at their own risk, knowing fully well their own limitations, if any. The topic for discussion for the 12th session on Zoom meeting platform on today, Saturday, 26th February 2022 from 6 p.m. to 8 p.m. Indian Standard Time is user-friendly interactive C programming part 3. Learn free from any place. Learn free at any time. Learn free at any pace. This is an Atmanirbhar Bharata initiative. About this lecture series, discussion series. Participants as well as the viewers of this program are welcome to use this programming using one of the following methods. Method 1. Participate in virtual session through Zoom. To receive link to join virtual session, send your name by email to x9t9@yahoo.com. Use the link to join virtual session wherever free Wi-Fi is available to save money. Method 2. If unable to join the virtual session for any reason whatsoever, link to view and or download the video recording of the virtual session will be made available. Use the link to view or download the video recording of the virtual session wherever free Wi-Fi is available to save money, and view the recorded video as many times as required in individual cases to become an expert in the subject without the need for constant internet connectivity. Method 3. View the downloaded video, which is downloaded on a USB pen drive, by just plugging it into input port on a TV to view the lessons on a bigger screen without the need for constant internet connectivity. About this lecture series and discussions, spread the message about the series of lectures discussions through all your contacts so that somebody in some corner of the world will be able to get some benefit either by attending the virtual program or viewing the recorded video of the virtual sessions. Those who wish to part with their knowledge and experience for the benefit of younger generation are welcome to send their name of the topic on which they wish to talk, and the date and time convenient to x9t9@yahoo.com so that arrangement will be made to accommodate them also. Everybody is welcome to donate the words of their wisdom in the form of honest opinions, meaningful suggestions, and constructive criticisms with the sole purpose of improving the clarity and quality of the presentations to be made in the future sessions in the best interest of the younger generation. A brief revision on what was covered in the previous session before introducing the new additional ideas on writing user-friendly interactive programming in C language using audible alerts wherever and whenever needed as desired by the programmer. C is one of the programming languages which is nearer to both users as well as the machine. C as a programming language has its own character set. The character set in C is broadly divided into three main types. They are letters, digits, and special characters. To make learning a language simple, the letters used in the C programming language are the English alphabets. That is, the uppercase letters, also called capital letters, also called big letters, and lowercase letters, which are also called as small letters. The uppercase letters are listed here, A to I in the first line, which are 9 in numbers, J to R in the second line, which are 9 in numbers, and S to Z, the third line, that contains 8 letters. So 9 plus 8, it becomes 26 letters, which are the uppercase letters. The handwriting style varies from person to person. The handwriting style of fonts available in the computer is shown here. What is important is, it is necessary to distinguish one character from another character so that there will be no confusion when answers are written in theory examinations, so that each character is identified from that of the other distinctly. The lowercase letters are shown in the slide. As before, the first line has A to I, the 9 letters, J to R, 9 letters, S to Z, 8 letters. Here, because of some automatic feature of correcting letters, the I is shown as a capital letter, but it will be a small letter only. That means there will be a dot at the top. The handwritten form varies from person to person. Again, the lowercase letters in handwriting font available in the computer are shown here. The digits are the decimal digits. Deci means 10. So there are 10 different digits in the number system. They are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The handwriting style again varies from person to person. Typical handwriting type of font available in the computer is shown here. What is important is the letters like capital letter C, the small letter c, and the opening bracket or parenthesis. They should be clearly identified from one another. Similarly, others also. So let us see what are the special characters. Now blank is one of the important special character. This is an invisible character on the monitor screen or on the printed paper. This is produced by pressing the space bar in the keyboard, and the cursor moves to one location without leaving any mark on the screen. So blank is an invisible character, and this is one of the special characters. So to show it on the paper, a small letter B is generally written and a line is drawn either horizontally or inclined at around 45 degrees to represent that that place is occupied by space, and it is produced by pressing the space bar in the keyboard. The handwritten form of the blank or space is shown in this slide. The small letter B is written here with a horizontal line drawn, like over striking. but the line can be inclined at around 45 degrees also as a style produced in handwriting. Apart from the uppercase letters 26, lowercase letters 26 and decimal digits 10, totaling 62 characters. The special characters are the others which are available on the keyboard. They are listed here. The first set what we see is something called the parenthesis. So this is called opening parenthesis. This is called closing parenthesis. They are always used in pairs. These are called braces. Some people call them as flower brackets also because of the shape. They are also used in pairs. Between this opening and closing type of brackets of all the varieties, whatever is information needed is written. These are called rectangular brackets or square type of brackets or box type brackets by different names. For performing arithmetic operations, we use the symbols plus for addition, minus for subtraction, star symbol for multiplication, and slash for division. Now here what are shown are the logical operators. They are like, these are also called relational operators. These are called relational operators. So it is something like equal to and not equal to. So this exclamatory mark is read as not. These are two different characters. So this is less than and greater than. These are also sometimes called angular brackets. Now less than or equal to makes use of two different characters written one after the other like this. Similarly, greater than and equal to also uses two different characters. So as far as the character set is concerned, equal to there is only one, like that. Exclamatory there is only one. This opening bracket of this angular type there is only one, and closing type there is only one. This is called hash symbol. This is called and symbol. This is full stop or decimal point or period. This is comma, colon and semicolon. This is single quote, double quotes. This is question mark. This is called backslash. This is a vertical line. So this is exclamatory mark which is used here in combination with the equal to sign to get the meaning not equal to. This is not used in the programming, but it can be used in the data processing. Dollar symbol, percentage, and this is for raising to power or exponentiation. This is called underscore. That means it comes at the bottom level of the character. Whereas this minus or hyphen comes at the center of the characters. Now what is important is the differences between the different letters digits, special characters is to be maintained. So one is capital letter C, small letter C and opening parenthesis. They should be distinguished. Number 1, capital letter I, small letter L. They must be easily distinguishable when written in handwriting, particularly while writing theory examinations papers on computer programming. Similarly, number 2 and Z, letter Z and number 2 must be written carefully so that one is easily distinguishable from the other. Similarly, number 5 and the letter S. 5 and S, when we write, there must be easily distinguishable characteristic so that we will not confuse one with the other. Similarly, number 7 and 1, there may be confusion the way we write. So generally when 7 is written, a horizontal line or a striking of the character is done so that it is easily distinguishable from one with a hook. Then letter 0, small letter O, capital letter O must be easily distinguishable from one another. Otherwise, we will confuse O with 0 or 0 with O. So best thing is to avoid the letter O wherever possible so that we can use 0 to represent 0 only. So we have around uppercase letters of about 26, lowercase letters 26, decimal digits 10, special characters. One is the blank space and 31 includes the relational operator pairs which are used in the programming. So blank space plus 31. Constants. From the dictionary meaning, if we see the values which remain unchanged during the solution of a problem is called as a constant. Example, we have used the Greek letter pi to represent a constant, the small letter g to represent acceleration due to gravity, which varies from place to place and also varies from time to time. But for a given problem, they will say in the question paper that take g is equal to so much for solving a given particular problem. Similarly, pi is the ratio of the perimeter of a circle to its diameter. E is the base of natural logarithm. Mu naught is the absolute permittivity of free space, or free space is also called as vacuum. Epsilon naught is also a constant. It is known as absolute permittivity of free space or vacuum. Generally, when we use the Greek letter pi, it represents the ratio of the circumference of a circle to its diameter. In the problem, they may give take value of pi equal to something as shown in the screen, maybe like 3.14, 3.142, 3.1415, 3.1415, 926536, like that. Calculators will display depending on what is the maximum number of digits the display can show there. Approximate value of pi is also taken as 22/7 for simplifying calculations and remembering the figure. Similarly, g, the acceleration due to gravity, is taken as 9.81 meter per second square. Some problems, they will say take g is equal to 9.8 meter per second square. There are also some question papers in which they will say take the value of g is equal to 10 meter per second square. This is just for simplifying the calculations. In the foot-pound second system, the value of g is taken as 32.2 feet per second square. Similarly, the value of g in centimeter gram second system is 981 centimeter per second square. E is called the base of natural logarithm. It has a value like 2.718 for 3 decimal places, 2.71828 for 5 decimal places, and 2.718281 correct to 9 decimal places. But after the 9 decimal place, the digits that come will not be repeating in the same way. Mu naught value is taken as 4 pi into 10 power minus 7. This is in Henry per meter. And epsilon naught is taken as 8.854 into 10 power minus 12 farads per meter. In mathematics, generally the letters in the beginning of the alphabet are taken as constant. So, we will try to use the letters, particularly the small letters A, B, C, D, E, F, G, H, I, J, K, L, M and N as symbols for representing constants. Now, although this is not a rigid rule that is engraved on a highly polished, hard, jet black granite stone. If we stick to these rules, it is fine. Otherwise, we will define what are the actual constants used in a given problem. For example, the Greek letter pi is used for representing constants while writing in hand. But there is no symbol for pi in the computer in the programming language. So, we can use something like pi, a combination of two letters, to represent the pi, which is used in calculation of different things which using the formulas containing the pi. The variables are generally the letters which are used at the end of the alphabet. So, we have used the letters from A, B, C, D, etc. up to N for representing constants. O is not used for either variable or constant because we may confuse with 0. So from P onwards up to Z, that is PQR, STU, VW, XYZ, they are generally used for representing variables. Here examples, we are using R, D, A, P as variable. Here we are not using the rules what we said, that letter A to N are generally used for representing constants and P to Z are generally used for variables, because we can define here something like R represents radius of a circle, D represents diameter of a circle, A is the area of the circle, and P is the perimeter of the circle. So by defining what each symbol represents, we will be able to prepare a list of variables and constants that are used in solving a problem. We will be using only algebra for calculations. We will not be using arithmetic. The difference between the arithmetic and the algebra is, in arithmetic, we cannot subtract a big number from a small number, because subtraction of a big number from a small number is meaningless operation in arithmetic. But in algebra, we can subtract any number from any other number. That is, we can subtract a big number from a small number in algebra, which is a meaningful operation. Example, if we write 4 minus 9, it represents subtract 9 from 5. That means 4 minus 9 will become equal to minus 5. So we will use only algebra in all our problems solving methodology. So it involves addition, subtraction, multiplication, division, powers, and rules. The symbols used between constants and variables, between variables and variables, for the purpose of addition, subtraction, multiplication, division, etc. are shown here. Plus symbol is used for addition, minus symbol is used for subtraction, star symbol or asterisk is used for multiplication, and slash is used for division operation. Raising to a power, we have a ready-made function in the C language. You can call it as a built-in function or a library function. So it is written as POW A comma B, means A is raised to the power B here and value is calculated. Similarly, for square root, we have a built-in function or a library function or a C language separate function sqrt within bracket x. Any value of x is given here, the square root will be determined by this function. Similarly, there is a function called trunc, that is trunc. Here C is missing, so within bracket p. So anything value that is of p is given to this trunc function, it will truncate and give the whole numbers only, ignoring the fractional part. So in addition to the basic operations of addition, subtraction, multiplication and division, we can use these functions which are ready-made available in the C language for raising to a power, finding the square root, and ignoring the fractional part and considering only the whole number part of a given value. We will take an example of a C program. Now we want a program which will do the following operations. That is, output we must start on a clear screen. That is, during the process of use of computer, the cursor will be located at some position on the screen. So before making any display on the monitor screen, we wish to take the cursor to the beginning of the first line on a new page. So that is done by a ready-made function supplied in the C language for the purpose of clearing the screen. That is, start from a fresh, clean screen. Then we want a message to be entered for the user which says please enter value of radius, so that user will be able to enter the value, and it is supplemented by a beep sound or an alert sound which will tell the user that computer is waiting for the input from the user, and by looking on the screen the user will be able to understand that computer is waiting for me to enter the value of the radius, so you can enter it once we see the display there. For example, if we enter 1.0, then area will be pi r square. Since r is 1, r square is also 1, multiplied by pi will be pi only, that is say 3.142 for 3 decimal places. Diameter will be twice the radius. So if radius is 1, the diameter will be 2 units. Perimeter is 2 pi into r. Now r is 1. 2 into pi means when you multiply this, it is 6.284. So computer will be displaying the values like that, and we want it to display please note down the results, and also you can give a beep sound for alerting the user that he can now note down the results which are listed above. So the message may say please note down the results, giving a beep or an alert sound. Then it may say please press the enter key to continue. That means after noting down the results, the user is asked to press the enter key so that it can go to the next processing step. Otherwise, it will be waiting for the user input. Next message is please enter next radius value or radius value for the next problem if we have some more problems to find the area, the diameter, the perimeter when the radius is given. So here a hint is given that user, after processing all problems or after processing one or two problems, instead of continuing to process additional problems, he can say I have processed all the problems that we wanted to process. I don't have any more set of data to process, and therefore he has to signal the computer by giving a value called as end of data criteria, which is designed by the designer of the program. So here 0.0 is used as end of data criteria because a circle cannot be drawn using either 0 as radius or negative number as radius, but the circle can be drawn with radius equal to any positive value. So, while processing all the number of values that we have for radius to determine the area, the perimeter and the diameter, etc., to signal that we don't want to process any more data, we can enter 0.0 as radius value, which will alert the computer that user has processed all the available data with him and he don't want to continue further. The control can be transferred from the C program, that is execution, to this operating system, so that computer can be made free and some other user can make use of the system. Now, when the user enters 0.0 as the data, the computer will print the message like processing completed, thank you, please come again, please enter, press enter key to quit. So again it will give a alert here. So when you presses the enter key, then the control will be transferred to the operating system and the computer becomes free for use by others who are interested. So the some functions what we studied like POW, SQRT, then TRUNC, these are called inbuilt functions or library functions. In addition, it is possible for users to write some functions which are not provided as a part of the library functions or inbuilt functions, and in such a case they are called as user defined functions here. So user can write their own function to do a particular job, which is used at several places. Now inbuilt functions include something like main. This is the first function which will be executed when the execution of a C program starts. We are using a printf function and a scanf function. This is for displaying information on the monitor screen, and this is for using the keyboard as input device. We have some blocks. The blocks are identified by a bracket, opening bracket of this type, or a brace, and a closing bracket or a closing brace. Between these two, whatever we write, that becomes a block. So this is called the structure of a while type of function. User defined functions, for example, in this problem we will be using beep as a user defined function, which is not there within the list of inbuilt functions. User defined functions, beep. So this one makes use of three functions. One is sound, another is delay, another is no sound, which are available in the DOS or disk operating system. So here is a typical C program. The first line include stdio.h. It tells the computer that user wants to use statements like this print here and the scan here, scanf and printf. How to do that operations using those functions is described in this file called header file. So we want to include that one so that we can use these commands like printf as well as the scanf. Now include conio.h. This is required because we want to use a function like getChe. We'll study later. Similarly, we want to include math.h if we want to find square root. But in this problem, there is no square root requirement right now. But if we take an inverse problem, then we may need a square root. Therefore, we can include this header file. Even if it is not needed, there will not be any errors or mistakes. But if we use a function which is not available, then the computer will not be able to process. So the square root function is needed here when we say area is equal to pi r square. Now if area is given and value of pi is either given or assumed, then r square is equal to area divided by pi. So radius will be square root of area divided by pi. So to use the square root function, this math.h file is needed. Include dos.h. This is required to use the functions which are defined in DOS language, that is something like sound, delay, no sound, which we will study later. Now void main is the statement. This void tells that this program whose name is identified by the word main will not take any output or input. So this is for output. There is no output from this main program, and inside this parenthesis we write something which will be the input data for this program. But in this one there is nothing here, so main function will not take any input and also it will not give any output. So that is indicated by void main and opening and bracket parenthesis. Now anything that starts with flower bracket or the braces, also there must be a matching pair at the end. So between these two braces, whatever comes is a program block. Now here we want to make use of a function called beep, which is not in the C functions library. So user can define this beep function. So it has to be told at the beginning of a program to indicate that we will be using our own program function like beep, open bracket, close bracket, and what is this will be given either before the main program or after the main program. So that hint is given by writing here void beep open close semicolon. Now the quantity of data or information which we are going to handle must be indicated about whether they can contain any fractional parts or they can have only whole number part without any fractions. So the radius of a circle always need not be a round figure, and even if radius is a round figure, when you go for calculating area or perimeter, there will be fractions encountered because of the use of pi, which is approximately 22/7, or it is like 3.1415926536 for 10 decimal place accuracy. The pi Suppose you take it as 3.142, which is correct to 3 decimal places, may be sufficient for solving many problems in schools. Now, as we said earlier, the CLR SCR is a function. It is a built-in function in the language. Its job is to, before the output of information on the monitor screen, it will clear the screen and the cursor will be waiting in the first line in the first position at the leftmost position on the first line. Now, this radius, diameter, area, perimeter and pi, we have assumed that all of them will have the fractional part also as value. Now, pi we are taking to 3 decimal places, which is correct to 3 decimal places, 3.142. Now, the first message will be printed is please enter the value of radius equal to. This is a hint to the user that computer wants to read the data from the keyboard. Now here this \n is called as a new line character. It is a combination of the two. What it does is keep the cursor on the first position of the next line. Now clear screen has taken the cursor to the first location of the first line at the leftmost position, but the new line character will again move the cursor from the current position to the first position on the next line, so that one line of gap comes at the top of the screen. Then it will print this message, whatever is given there within the quotes, that message will be printed there. Now, to alert the user that computer is waiting, he will also, a beep function is used, which is user defined function. So it produces a audible sound to alert the user that the computer needs input through the keyboard from the user. The scanf function, which is defined in the stdio.h header file, it waits for the user to enter the data. Here, the first one is a specification which tells how the value of radius looks at, whether it has a fractional part or not. So here, generally, we want to keep a fractional part. Therefore, we will use this character code here or specification %f. This and r is used as the radius symbol to represent the radius value. This and r, when you write, it says it is called the address operator, and value of r entered by the user will be stored in a location which is allotted for the variable r by the compiler. Once the value is entered, we will check here whether the radius value entered is greater than 0 or not. If it is greater than, we want to do this complete work enclosed between this brace, opening brace and a closing brace. If it is not greater than or equal to, that means if it is equal to or less than or equal to, we know that a circle cannot have 0 as the radius or negative number as the radius, and therefore we will not use it for actual calculation, but 0.0 as radius value is used as a signal to tell the computer not to calculate the value, but to transfer the control from the program which is under execution to the operating system, so that the computer is made free and someone else will be able to use the system. So, if the value of the radius is greater than 0.0, then value is calculated using this statement. So, this is called assignment statement in some other languages also. What it means is the expression on the right side of the equal to sign to be calculated, and result is to be stored in a location which is allotted for the variable a in the memory. Similarly, d is the diameter of the circle, r is the radius. Here diameter is equal to 2 times r also we can write, but it is better to write r plus r because addition is the fastest operation in the computer. Then perimeter is 2 pi r. Now 2 into pi, the pi value we know it is 3.142. So instead of asking the computer to multiply 2 multiplied by 3.142, if we multiply ourselves and put the value here as 6.284, we can save probably a microsecond processing time in the computer, so that calculation becomes faster. So we will write multiplying 2 pi, we write it as 6.284, which is multiplied by the given radius to get the perimeter. Once these calculations are over, it is always better to write the input data also. Here input data is radius, output data is area, diameter and perimeter. So we'll write all the four, that is including the input data, so that if answers printed for area, diameter and perimeter are not suitable one, we can find out what was the end value that was entered for the radius, if radius value is also printed along with the results of processing. So this is because of the jargon that is familiar in the computer or electronic data processing processes is called as garbage in and garbage out. That means if we supply wrong data, then the results produced will not be useful. So once these values are printed, we want the computer to halt and wait, so that the user can note down the results by looking at the screen onto his notebook, etc. So for that purpose, a message like please note down the results is displayed, and then a beep alert is also given, so that to tell the user that it is waiting for input from the computer. Now please press enter key to continue. A message will be there, and there is get.che. This is available in the conio.h file. Then please press enter. Next radius value also given, and here a hint is given that if he has processed all the data, he can as well enter 0.0, so that he can exit from the execution of the program. So when the value of r is read here, if it is 0, it will not perform calculation. If it is other than 0, it will repeat that block contained in the between the two braces of the while statement. So if it is 0, then it won't go back to repeat the problem processing, but it will print this message Processing completed. Thank you. Please come again. Please press enter key to quit. So any message like this, user can decide and write it as a problem. Now beep is used to give an alert to the user that it is waiting for some input by the user. The get character function will allow us to accept any pressing of any of the keys on the computer screen, but we try to specifically say press the enter key so that the user will be forced to press forcibly asked to press the enter key to do the needful. Now the beep function, which is a user defined function, is written here. So this consists of the void beep open close. It means it does not need any input here for working. It doesn't need any output also from the function. So it uses three different functions. One is called sound, another is delay, another is no sound. So this sound 200 will give the particular type of tune, and this 500 is the duration, how long we have to wait. It is like in milliseconds, that is 500 milliseconds means it is half a second. So a sound note of 200 note that corresponds to a particular note will be there for 500 milliseconds, and afterwards the no sound will come. That means it works as a beep. Now every function must have a return statement. Generally it is written like that. So that means where a beep is used like this in the program, it will come here, perform these things, and before going it will be noting down the position from where it is leaving, and when it comes back it comes to the next statement in the line and continue with the other processing steps. So typically a user defined function can be written like this also. The semicolon terminates the every statement in the language. Let us take another example. Problem description. Problem description is something like this. An educational institute has 10 classrooms to accommodate standard 1 to 10. The number of students in each class is different. One classroom may have 17 students, another have 22, another 33, another one 60, another one 45, like that. On an average, there are 6 subjects are taught in each class. That means 6 into 10, there will be 60 subjects will be there. It is required to enter marks obtained by each student in all subjects into the computer to determine the class average marks in the particular subject, and therefore classify the students as those who belong to the above average category, below average category, or average category if possible. The purpose is to arrange special classes if necessary to all those students who will be found as not above average, as also to enable those students who reach higher level in performance in the future tests and examinations. It is also necessary to determine the deviations in the marks scored by the students in the examinations from the mean value for each class in each subject, and hence to determine the standard deviation. So the requirement, we can write it something like this. C program is required to read a number of numbers using something like end of data criteria. That is what we used in the previous example. Determine the number of valid numbers read. That means how many numbers are there in each classroom, in each subject, in each class. Determine sum of valid numbers read. Since the total number of students are not fixed, they may vary from one class and one subject to another class and another subject. We can ask the computer itself to determine how many data it has received. So determine the sum of all the valid numbers read. So if students score marks like 17, 13, 25, 15, 10, like that, then add all of them, that gives the sum. Determine the average of numbers of the numbers read. That is, once the sum is known and the number of numbers is known, we can divide the sum by the number of numbers to get a average value. So determine the deviation of the numbers from mean value for each of the values that are read. Classify the numbers as below average, above average, or average if it is possible. Determine standard deviation of valid numbers which are read, and display the interaction between the computer and the user, including intermediate results that are calculated. The program goes something like this. First is include stdio.h. It is used because we are using printf and scanf statements in our programming language, so that they are available in stdio.h and it can be taken from there. Include conio.h. We are using get che, which is defined under this program. Include math.h. Here we are using square root function. Include dash.h. This is using something like sound, delay, and no sound. So here actually the size of the font is increased here, otherwise this should have come at the end. When it is used as a statement in the program, each one is terminated by a semicolon. Here we are only telling that we use the sound function, delay function, and no sound function, which are good descriptions are available in the header file named as dos.h. So after that, preprocessor directives. The first line will be the void main. So this void tells that no output from this function, and the empty space between the two parentheses indicates that this function does not require any input also. So the work will be started from this opening block till we find the matching closing block. So void deep colon. So here colon is used. This will tell the compiler that user has written a user defined function called beep within bracket within bracket the parenthesis here. So void will tell that no output will come from here, and this is something like method of declaring the use of a function whose details are available outside the main program. Now here, since the marks scored by the students in each subject, we are using two times. Once while finding the sum and average of numbers, we are reading the individual value. Similarly, when we are trying to find the deviation of each number like x1, x2, x3 from the average value, say A. Then also we will use one more type. That means one more time we have to give the data. So here these variables we have used before, they are called as simple variables and they cannot be reused. That means without producing any changes in the value of either the value of any number that is required 2 times. So for that purpose we will use in technical terms what is known as a subscripted variable of a single subscript variable. In this case, between the two rectangular brackets, what you are giving is something like the item enclosed in the bracket. Here it is 101. So the locations in the computer memory for X with one block will have 101 means 101 locations. The numbering of the locations starts from 0. Therefore, actual numbers will be there from 0 to 100. So therefore, generally we don't want to use 0. So we will use the numbers from 1 to 100. So therefore, though we need 100 because counting of the address starts from 00 to 99. We have increased it here to make it 101 so that we will use number 1 and up to 101, which will become 100 numbers for the locations in which the values of the marks scored by the students in a particular class, in a particular subject may be stored there. A is the average value obtained by taking the sum of all numbers dividing by the number of numbers here. Only thing is these are in floating point format and these are in integer format. So we will do necessary conversion before using the value of n in the calculation step. Now d is the deviation from the mean value. So if the average is a and actual is like x1, x2, x3 like that, then a minus xi, a minus x1, a minus x2, they are the deviations from the mean value. So that is indicated here d. The product of d or d square is stored in another variable like this, which is user defined. Then the sum of all the squares of the deviations are stored here. Dividing that by the number of numbers, we get the mean value of the deviation, or it is called mean deviation, and SD is the standard deviation. Here we will use a character Z, so which will store either capital Y or capital N. This we will use to indicate end of data criteria. That is to say, if user inputs y, that means he want to repeat it, the execution of the program for another class or same class for different subject. And if he tries to put the value of z as n, then he has finished the all processing of all classes and all subjects, and then he is indicating that it is the end of data, so that the transfer of control takes place from the program to the operating system, and computer is freed so that someone else can use the system. So here the type of logical operator equal to here, we have to use the double. If we use single, the meaning is different, the value will be stored there, that's all. But if it is like this, then it will a comparison or checking whether it is equal to y or not. These two vertical bars indicate the OR operation. So this is called a logical operator, whereas these are something like the equality operator. So depending on yes or no, first time we have started with the z is equal to y, so it will be done here. So yes will keep the all the numbers which we input, their sum will be kept there. To start with, we have n is equal to 0, and we are taking the first data entry, that is I is equal to 1. So we are clearing the screen and keeping the cursor in the first line of the new screen. So the message welcome comes giving one line gap again, that means top one line is not used. After printing the welcome message, cursor will automatically go to the beginning of the next line. Now this will again go to the beginning of the next line. The cursor will be taken to the beginning of the next line. It will print this message, please enter number, that is in this case I we have kept 1, so it will say please enter number 1. That means first value you have to enter. So beep is for alerting the user that computer is waiting for input, and scanf will wait till the operator enters the number that is asked there. So it will read that value. So here we assume that each of these numbers contained in x I, where I we want to use from 1 to 100 like thing, they are all of floating point type. That means they have fractional part also, and they are not the whole numbers. After user enters the data, we are trying to print out what was the serial number of the number that we have read and how much was the value. So we want to repeat this by using end of data criteria for the first data that we are using, so that if xi happens to be in some ith position and the number entered is like 999, because this xi is a floating point format, that means it does not represent always integer numbers. So we cannot check for exactness when you have the floating point number, but can be used for integer numbers. So here we will say is xi less than or equal to 998, we say, though we are writing input data as 999. So that means if the number is equal to 998 or more than that, we don't want to process, but we want to exit from this block of instructions which are following here. So one thing is S was earlier kept 0. Now for that we add the first number. So first number will go and stay in the memory location which is allotted for the variable S. Now we will increment the number. Earlier it was 0, so 0 plus 1 will be 1. Similarly, I was 1, now it will become 2, I plus 1 is 2. We print here S, sum of all the numbers we have read which are valid, and N is number of valid numbers we have, so that supplying the S and N value, please enter percentage the I. So first number we will be printing. So beep is an alert, and this function will wait for the operator to put the input data. Then we want to print it here. I is, what is that number? This is in the integer type of format, this one. And X of this number will give the F, floating point number. So once all the numbers are input and 999 is seen, we will have A is equal to S by float n. So this float will convert the n, which is integer, into a floating point, and then it will use in the expression of S divided by that number. Now we will print here what is the sum of numbers individually and what is the serial number of the number, or the first, second, third number, like that, and then we will write what is the average value also. Now these operations like while xi less than or equal to 9 and 8, we try to repeat whatever is given here. Now it is necessary to know that D is the deviation, which is average value minus individual value for different i's. D2 is a variable we are using for D square, but we are not squaring it, we are writing it this way. It is D into D. Then sum of all the squares of the deviations, we keep it in ds. So that means ds originally empty, we keep on adding d2 and we get the total. Now I is incremented, n is incremented, and the process is repeated. So after the completion, we will find the mean value, which is the sum divided by the n after converting n into a floating point format. Then SD will become square root of this mean value. Now these values are written here, that is what is the standard deviation and what is the number. Then it will say, is there one more problem to solve? So please do enter Y to solve another problem, or enter no to quit processing. So this beep signal will alert the user that it is waiting for the input. Scanf will be waiting for the user to enter the value for Z. So after that it will print what was the NZ value and what is the Z value that was read here. So then please press enter key to continue, message will come. So it will be waiting for that. So depending on what you are entering, either the process is terminated or it goes for repetition, depending on our requirement given in our own program. So when it is completed, it will say a message like, thank you, please come again, please press enter key to quit. So then this gets it, he will be making the user to wait, and after entering it goes out and return controls, transfer the control to the operating system. So user defined function C is a beep program, and it uses three functions: sound, open close, delay, open close, and no sound. So this 200 gives the type of sound note, and this gives the time in milliseconds. So 500 milliseconds, it means it is half a second. That means this sound will last for that 5 milliseconds. So therefore it looks like a beep. Example, you can have, let us say, 5 data are there, marks scored by different students in a particular subject. So 17, 13, 25, 15, 10, and we use end of data criteria, that we try to give a value like 999 as a data, but this is not for calculating and printing the results, but to signal the system that our processing is over. Then after producing or exit from the program, control may be handed over to the operating system. So sample output, first is clear screen, it will take the cursor to the first line of next page. So it will say please enter number 1. So user, let us say, you will enter 17. It will be actually waiting, giving a beep sound, and this one will collect that information over there. Now we want to print it here to check what you have entered is right or wrong. So this one is here and this 17 is here. So that is end of data criteria is using. Now it will immediately give what was accumulated so far and what is the number of numbers involved. So it is first number 17, only one number received. Now second we are putting 13. So this 13 plus this will become 30, which will be the interim result of addition. So that 13 is coming here. So I is equal to 2, second number entered is 13. So that will come, this is for our cross checking. Now adding 17 and 13, it becomes 30. So far we have read 2 numbers. The third number we are entering 25. So that will be displayed here, which is indication that whatever we have entered is taken into the computer as it is. Then adding that 25 to 30, it will become 55 items, and so far 3 different marks are added over there. Next it is 15. So adding that 15 will become here 70. So after 70, that is 4 numbers over, fifth number is 10. So adding here it becomes 80. 80 by 5 will be 16. So 16 is the mean value. So then it will give the deviations also like this, and negative indicates it is something like so this is average value, and the deviation is calculated as average minus individual value. So 16 minus 17 is minus 1. 16 minus 13 is 3. 16 minus 25 is minus 9. 16 into 15 is 1. 16 into 10 will be, that is 6. So standard deviation is calculated using the formula. Then it will ask for whether to repeat another problem, whether you want to execute. So here user is given option to press either Y for entering, repeating the execution for with some other data set, or N to exit. So the program we have used to check for capital Y as well as for small y, because some user may forget to either press the exit key or the inlet key for the head. So if Y means it is repeated, N means it is not repeated. So what you have to do is, here we have given the order different thing to check whether working is the same thing. Like that you can do, or you can have a different set of data, and same steps will go away and you will get the same answer for this, because the order or sequence of the data is changed but not the problem itself. Same thing here, the same data is written in a different order, but answers will be same only. So sooner or later, necessity comes that processing of all the data is over. Now the operator wants to make sure that the computing system is given a rest. So it is necessary to complete the processing step and exit from the control of the program to the operating system, so that somebody else can use the computer for either same or for different purposes. So we will stop here. So using these principles, whatever we have learned, try to do the problems for using more number of data in different number of for each class and different subjects, so that you will gain experience. Once you write the program without referring to anything repeatedly several times, reading through the file, you will become an expert programmer, so that you can instantaneously do the necessary action, so that the work is completed by the computer and the control is handed out to the operating system, so that the computer is freed for use of somebody else. So thank you and goodbye. Let us continue to do the lessons as per the schedule on the next Saturday at 6 p.m.